what I will be covering much more on connected self. So there are a bunch of these technologies coming together, right from the devices to the efficient communication, big data, machine learning, all these things putting together that has created all this opportunity in the space of big data, and particularly to the how it innovates to the healthcare itself. So connected health is this paradigm is that there are different players in managing the health, and we are at the center. The person, the human being, is the center. It could be hospital, could be labs, could be caregivers. Caregivers are the people who come at home, then emergency services. Then we are now equipped with all these smartphones and wearables. So that completes the picture. So our body, ourself can be continuously connected, plugged into, just like any other device, and can be monitored, whether we are anywhere, whether we are in office, whether we are in home. Our data can be, of course, to us, and if we allow authority to our doctors or any other, or even our in case of older people, if parents allow to children or other people, they can monitor the health. That's one side. Another side is that the EHR itself, the electronic health records, they are now available on the public clouds with the right security, and with the help of the integration and connectivity, all these things can be put together, and that's what we call it as a connected health itself. I'm sure that among these hundreds of different apps, you must be having one of them. How many of you having anything which is related to fitness or wellness applications? So almost half of 60%, and very soon the rest of you would be having that. I was just today morning I wanted to capture some images, and I thought that I would just get hundreds, but there were more than few hundred of such applications were there in this just in a Apple iTunes store. So quantified self is not a new concept, in a way that our identity, when we define, when we are growing, initially we can introduce as a, say, human, like I said, name, and then very next question would be always had been that, hey, how old are you, which grade are you? So that way we express in terms of the numbers, and then, but these numbers were not really attributed to your physical data. And subsequently then, if you are applying, putting your profile on, say, dating site, etc., you can put your height and body and all that thing, but it is still is a static data. So the quantification was there, but that quantification was not the quantification which can be monitored and which can be fed back to you in improving your health. So now with these wearable devices, smartphone, there are many of these quantification or quantifying a human being is possible, and few of these things are based on consumption, like how many, say, calories you consume, how many, say, water bottles you are consuming a day, or a particular food item, or even alcohol, cigarettes. All these things are one way that you can quantify, and it can be connected directly influencing positively or negatively to your health. Another could be your physiological stats, your heart rate, blood pressure. So these are the sugar level. Then the physical activities that you do with Fitbit or whatever the application that or the device that you are having. With that you can count how many steps that you traveled or walked or climbed, miles you walked, or so all these things are another example of the physical. Mental health, there are a lot of applications which can monitor. There are some applications or the wearable devices which can take your skin temperature or connect to skin and then find it out, your stress level, anxiety, etc. But others are based on social media or other aspect where it is not really tied up to your physical, but you are tied up to your social activity, and then quantify you to your mood swings or your stress level, etc. And medical symptoms tracking. So people who are having some illnesses, they do track their symptoms. It could be anything, whatever that their sickness is, and that can be tracked. And finally, some body functions. So these are the very few things of the quantifications. Some useful applications, those who are like this having sleep problems, so sleep monitoring, those who are in the restless leg syndrome, so they can get the devices, wearable devices, and monitor their restlessness. So fatigue detection, etc. There is one interesting one that I came across, which is a gene trainer, which basically does your DNA profiling, and then based on that recommend you some physical exercises. So it is a genetically guided fitness. And now, how do we get that information other than the self-entered or the social media, etc.? There are two common things right now. One is the smartphones, and smartphones have amazing features, rather the sensors built in. Like some of them, like gyrometers and then accelerometers, ambience, microphones, etc. So they can be used to track you to, or at least your activities. So your location, your activity level, etc. And the wearable devices, of course, the Fitbit, Aerobrist, Om Signal. Om Signal is very interesting. These are just limited. These are not, I'm not like promoting them, but some of them are popular, and some of them I've felt interesting. That Om Signal is a biometrics tracking shirt. So it can basically track your biometric parameters just by your wearing a shirt. So it is not the shirt itself, you are becoming like a device. So now we got all this quantification. And next thing, that where does this data go? Of course, we can see on a mobile device or something, but the historically, whatever the data, the history of the data, where does it reside? So it resides on phone, and many of these applications, they put it on cloud, like a Fitbit and Jawbone, they have their own cloud, and there you can put out your data over there. So, and that data can be shared. Now Apple has came up with Apple Health Kit, and so to tackle one problem, because there are so many applications, and each of these applications now putting the data, the same data, could be number of calories you burn or steps you have taken, but each one of them expressed in a different way. And so there is no common standard, so that is a big problem. So Apple said that, hey, okay, we will take that ownership, and then all these applications that can create the data and store the data in the same way, and others can consume that. Of course, the right model would have been on the iCloud, but then initially Apple barred all these applications to put that data on iCloud, because they wanted to, of course, provision their own health kit on a cloud, so that we can understand. So initially it was stopped. But still, Apple Health Kit is not the only health kit. So there is a Qualcomm has, and then Google, of course, and then all these different things putting together. So there is that issue of non-standard. One can say that in Silicon Valley, Apple itself is a standard, but there are many devices, many places, so there are all these standardized lack of standard, and then there is a lack of openness. So these are the common issues about how to put together the data, how it can be used, and so the first thing on anything that we do is that we got this data, we captured the data. Now we felt good initially that we look at the data as of now, but then we need to know that how are we doing over a period of time. So that's where the whole history comes into the picture. So some of these apps do provide the historical data. It could be a day, a week, or months. So most of these algorithms working on this data, they are mostly statistical algorithms. Some of them can be analytical algorithms. You can say that it can look at the trending, that how is your trend, how are you doing compared to say last week or last month, and those type of trends it can put together. But most of these applications are not really that way smart. It doesn't have that intelligence. When I say intelligent, it does not look at the data and then interpret the data and learn from the data and then predict the future from the data. And not only that one snippet of the data or the data stream, the more fun is that all these applications right now are the silos. So Fitbit will have data at one particular category, then MyFitnessPal will have say your calorie consumed at food, etc. Then sleeping related would have the sleeping patterns. All these things are informations are silo. The interesting health patterns can be detected, and then corrective or the preventive actions can be taken when all these data streams can be pulled together and some algorithms can be applied on top of that. So that's where the machine learning comes into the picture. So of course the machine learning can apply on one stream itself, but it makes sense that let's look at that how many physical fitness activities that you are doing in a day, that how many calories you are burning, steps you are walking, etc. Then correlate that with the fact that your MyFitnessPal is giving calories burned or calories consumed. So you got another data stream or that. Then you have sleeping pattern, that whether you are having the right sleep or not. Third thing could be that how is your anxiety level, stress level, and all these things, all factors contributing to your blood pressure. If you are diabetics, these are all the contributing factors, either positively or the negatively. So how can we put together all of this and then based on that detect or at least predict how are you going to do, and then possibly recommend certain corrective actions. So that's where that putting all these things together and then applying the algorithms, that's the really going to benefit the individuals and do some of the recommendations which can be corrective, so that in future any issues like, so for example, the DNA based personalized drug delivery. So that is the one example. Another example is that some of the apps are tracking your drugs consumption, that whether you have been given prescription drugs and whether you are consuming them. And of course some of the apps actually put the wearable devices, or not wearable, the sensors on top of your medicine box. So how many times you are opening, and then whether you are opening on the right time, etc. That is being tracked, so that whether you are consuming the medicines as per the schedule or not. So that is being tracked, and that helps in making sure that if you are missing medicines, then you get some notification alerts, so that you would be reminded to take the medicines. So that these are the various things that possible applications. So in the summary, that learning from various data streams like calorie consumption, exercises, barometric parameters, etc. Then correlating to classify you into either in the category or give some wellness score or the risk score to that individual who is being monitored. Then predict the impact of the current activities in the future wellness, and finally recommend certain activities. So that is the scope of machine learning in influencing individuals. If you take it further at the population level, then its scope is huge. Like in the current cases of this Ebola there are model, and that is for Ebola case in United States when that nurse traveled to Cleveland and went back. Then the biggest issue was that what could be the impact and what could be the propagation if anything get contagious. Of course, the sample model required for any kind of this modeling is required high, and in this particular case the sample was very good, so that is very less. So the typical machine learning algorithms would not directly fit into that, but graph algorithms fits into that model, where you can look at that how it can propagate, graph and clustering both putting together. But recently there is I think another competition was there to come up with these propagation models, and it was very successfully tested based on the past data. So that is one example that how the population health, and the CDC typically does it many times, this type of a modeling. Another is that outbreaks. If there is an outbreak is happening, flu pandemic happening in one particular area, the CDC tracks it, and there are various ways. The sensors could be, you know that Google did that the flu monitoring, and so just by the searches people are doing, based on that in a particular geolocation and the trending and all that thing, it can find it out that how many people looking for certain type of symptoms or medicine. Based on that you can decide whether this particular area has been affected, not affected, etc. Of course, in that particular case there was a bias, because in another example of when Hurricane Sandy came, at that time Twitter analysis was done. Yeah.
So my understanding of what you're saying is that this machine learning is a kind of a correlation of different data streams together. So
machine learning, it is a very narrow definition. It is not the full extent. What I'm saying, that applying machine learning to in the domain of the healthcare for a specific problems, it can be starting with the correlation. But machine learning scope itself is a very high.
The initial correlation is informed by human beings.
It's not necessary. Like let me say that the machine learning. So machine learning has a two aspect of that. One is a supervised, another is unsupervised. So in case of the supervised, it is, we can consider as a labeled data. It is a human who tags the data and say that this is what the result. So that is used as the training. But many times that there is no training data. So in that case, you start with the unsupervised data, and then go with apply the algorithms which are unsupervised one. So it has both. It's not the only one. So I would just walk through just higher level data science, because we got the data. So far we reached to the point that we got all this accumulated data, and we also understand that this data in a different format, but we can put together in some format. That is another we found, and we found that there are machine learning algorithms which, if we apply together on that, we can get some value out of that. But how do we reach there? So is there any kind of magic bullet that we hire one guy and then he decides that there is one X algorithm, so I apply that and it's done? So that's where that the whole data science come into the picture, which is the data itself is you can think that it has to go through the cleansing, because that data formats are different, data types are different. I was mentioning about that. Data might be missing. So you basically cleanse the data. That's one thing. But then afterwards, this data goes into some of the data can be used for the training purposes and the exploration purposes. So exploration is a very important part of this, the whole data science. So you try with various algorithms, because each algorithm may give different result. Which algorithm fits to your data is very specific to data itself. So there are some standard techniques that data scientists would run through the algorithms and then refine it. There is also intuition built into that. But at the same time, there is a plus and minus part of the intuition. Intuition could be a domain knowledge that, hey, we know that there is some impact of calories on, say, consumed or burnt on diabetics. So let's correlate that. So that is the intuition. But intuition also make you biased and you overlook certain signals. So data scientist typically needs to be open-minded in catering both type of needs, so that you won't miss some interesting facts which may be coming out of the data itself. So machine learning, as I mentioned, that there is this, there could be with training, supervised, unsupervised. And then this typically the flow is that you can, after you find that this algorithms really fits into your model, you build the model, and then around that model you build your application, and then application then you are putting into the production, which can have the data streaming coming into that, applying on that data, and then provide the results into either in the visualized format or some notification, etc. So I am putting the very broad level and covering a lot of territory. So there are two the higher level use cases I am covering, one on the personal side and another on the population health side. So use cases that say illness and disease detection, then wellness tracking, monitoring post surgery or post procedure recovery. So these are the few applications that if you are doing. And then data sources, as I mentioned, that it could be apps, it could be wearables, it could be human monitor or some equipment attached to your patient monitoring system, etc. The typical algorithms in this particular case, like detection, for detection purposes, you can use genetic algorithms or classification algorithms. Random forest is one algorithm which does not give the excellent result, but on an average it gives better results, because it really samples and splits the data into larger samples and then builds the decision tree continuously, so that and then you can create a average out of the results and pick up the result out of that. So that way, there are various these algorithms for the wellness detection. It could be statistical algorithm, or it could be this typical moving, trending, moving averages, etc. The constraint over here is that the data privacy and security, which are of course everyone's concern, at least the people who are sharing the data. The second thing that I mentioned, lack of standardization and the integration. These are the common for both the population side and the individual side. Now the individual side, on the population side, the outbreak, pandemic detection, contagious diseases, propagation models, trends at the societal levels, and the trend is something which is a very closely monitored, because the disease related directly measurable are one thing, but there are very influential long-term trends are like obesity, hypertension, diabetes. They are not instant killer, but at the societal level, when it increases to a larger level, then the overall health of the society goes down, the cost of healthcare goes up. So these are the issues which needs to be monitored. Like for example, the correlation between all of us, or the current generation, or the Gen Y, Gen X, right? They are, as compared to the previous generation, like a baby boomer generation, there is that eating out is a much more common. Most of the people do not eat at home, and of course when you eat out, that has a correlation between that eating out versus the impact on obesity or overall health. And when almost 60-70% of the population is eating out daily, it has a wider impact on the societal health, and of that again the cost of the Medicare and health goes up. So these are the issues which are not really the contagious diseases or pandemic, but it's a long term and silent but very huge impact areas. So these are the areas you can monitor and you can correlate, and certain recommendations can come out of those. So there are the top algorithms. If you want to list that, what are the top algorithms related to the machine learning, And then I would say that I would be sharing this slide deck. So the classification algorithms, decision tree, regression algorithms, then correlation, then associate rule mining, which is typically like say market basket analysis type of thing, that who like those who bought diapers also bought, is a famous example, also bought beer. So they are like associate rule mining, that how, and that is very heavily used in advertisement also. So that's like say so then in case of the collective intelligence, etc. Deep learning is a very interesting field that nowadays coming, which is during particularly image processing, image correlation, could be finding the forensic, matching of the images, video, those type of application they are using the deep learning aspect. So now what are the platforms? So we looked at very higher level algorithms and which algorithms fits into what type of problem, that is also matrix. I gave some of the examples for some of the use cases, but when you go deeper in each of the use cases also, there are out of the variety of application which algorithms might be suitable to you, and many times there is a practicality or the reality is there that one algorithm, though it is best, you may need to augment that. So typically that's is an ongoing process. Now the platform side, if you hire data scientist, because that would be the first thing that the data scientist or your person who little bit knows stats and machine learning, etc., quant. So these are the typical tools, and it could be driven by the person who is actually leading, because some of them might be very comfortable with MATLAB, and they would not be comfortable learning say R and doing processing over there. Python has a great number of packages, NumPy, Scikit, Skylern, these are the few, MLPy. So these are the examples of Python itself. And on Java side, Weka, Mahout has been, but they are not for the data scientists, they are mostly for the developers. So these are the various algorithms. I mentioned the Spark is a big data platform, and it has a MLlib, and MLlib has also you can do interactively, so that way even the data scientists can easily use that. So that's why I'm putting on the Spark both on the data scientist side and the developers. But once you create the model, algorithm, etc., and you want to make it in a production, you want to create a system, you want to put it in a pipeline, and the massive data is going to flow through that. At that point of time, you build a big data platform, and big data platform using one of the technologies like Apache Spark. If you are going with the Hadoop, Hadoop has a lot of other open sources like Oryx coming from Cloudera. Then Revolution Analytics has put R onto Hadoop. Similarly, Graph Labs, which is also handling a massive data and is a very good for machine learning type of applications. This Wapal Wabbit, it originally came from Microsoft. Few of us might have heard, and but it is a very powerful machine learning platform. So on the Oracle side, we have a cloud-hosted platform which can handle the heavy volume of the data. It can be integrated, plugged into this the platform. It is built on cloud technologies, so it can have the scalable, elastic, and pay-per-use type of a model. Then both at the storage, at the compute level. It has standard technologies that I mentioned, whether it is on the Hadoop stack or Spark. And then highest level of the stack is that different applications. One of that I mentioned is that data cleansing, data discovery, or finding out the patterns from the data and then presenting. So providing tools for data scientists, providing a platform for application developers. So these are the platform itself, we have it. So whether we you can build the similar type of a platform, stitching open source technologies together, which is a hard work, but people do that, building a platform. So in a summary, that in the machine learning, what we have, that we have the platforms, we have the algorithms, we get the data, we need to put the pipeline together, then initially do some data analysis, finding out what we can correlate, what we can get out of it, build your model, and once you are comfortable, then you can put into the production. And of course, the beauty of the machine learning type of algorithms, they are one is self-learning. So continuously you need to, don't have to basically, if you go with the rule-based systems, things change, and then you implement and customize again the rule extent, need to do that. Machine learning type of platforms, they are that way self-healing or the self-learning, so that it can keep on adjusting to the new data points and still function. So of course, over a period of time, you may need to rebuild your model. So it is not like going to be permanent. So after some time, your new things come up, but your model has inbuilt bias, and to get out of that bias, it may take, like say, disruptive technologies come, and then your model might not adjust immediately. So in those cases, you may end up rebuilding the model itself. So that's all I just wanted to cover end to end, from how the whole picture of sensors, wearable devices, communication, then big data platform, and machine learning, all the fits together, and how it can apply to solve some practical problems, so that we all go towards some better life, and as a society we can be a healthy and well society. Any questions? I would be happy to cover.
Well, I have a problem in that I took my blood pressure 3 times a day for several months, graphed it very nicely, brought it to my doctor, who says he wasn't interested, he wouldn't look at it. He took my blood pressure 1 time in the office and wrote it down.
Yeah.
Now,
So
the problem is obviously that doctors can't use data that they did themselves.
So there are certain companies are coming forward, or even the medical like a insurance provider, the care provider, they are certifying the apps. They would be certifying the apps, because doctors can't trust it. Your app, right? Your app, you tested it, but who verified it? Who certified that really is like whatever that the blood pressure it was showing to 120 over 80? Was it 120 over 80, or it is 70 by 140? So doctors can't trust it. So doctors, that's why, because unless it is certified, because it's a risk, you will sue them later on. You will not sue that app provider. So medical providers, so that's why there are some issues coming up with this technology and standards. So that's it's still work in progress in that area.
Yeah, I mean, it's the whole problem with large amounts of medical data, because the same thing, I step on the scale every day, the doctor's going to say that scale could be off 2 pounds.
Yeah, exactly. But see, what is the important factor is not the absolute. That's where the whole machine learning, etc., comes into the picture. That first we do is that capture your baseline, and then look at the trend. I don't care that whether that blood pressure is like 120 by 80 or whatever that. What I am interested in, rather will be able to demonstrate, is that over a period of say 7 days, are you doing better or you are doing worst? Right? If you survived 7 days back, you may survive today if you are doing better. So that way the trends are very important. And then the next thing that over here is that the correlation. Still doctors would make their own calls. So it is not really the self diagnosis. It is not to the level that this system itself will do the prescription. So I don't expect that is going to happen.
And then I absolutely don't want my insurance company to know any of this data.
So it is a plus
They
and
would take it, and so the people.
so it is a pricing model.
Yeah.
If the current pricing insurance company is that is like is based on the if there are 4 players are there. One is that the actual payer, which is your company where you might be working or yourself, then the actual insurance company, then the actual care provider, and then that is the hospital. So hospital get paid for the procedure they are doing. So they are not interested in keeping you healthy. If you are healthy, you won't visit. If you don't visit, they won't be able to make money. So there is this, but if the model is changed, if the model is something like this, that you get that money and then you save by keeping people healthy, and that's where many companies, big companies, they are actually doing that, the whole wellness programs, and they are negotiating based on the wellness of your employees. So then they give that the fixed amount, irrespective of whatever the services, etc. So that way the incentive is not to keep you treating, but to keep you healthy. So there are certain issues are systematic issues. That is not really the technology issues. Just in that case. Yeah. Oh, yeah.
The thing you talk about is your own research or is it Oracle product, service?
Yeah. So the question is.
The question is the topic you talk.
The first part, the field, etc., the healthcare, etc., is my own. The last part, that the platform is Oracle, right? Yeah. But the research is something. The algorithms is a research. The platform is a technology.
Okay, all right.
Yeah.
I was curious about the algorithms and the potential for big data. So I work in healthcare, and I see that we're starting to go in that direction, but we're not really using a whole lot of big data analytics.
Uh-huh.
What do you think in terms of how mature is the technology right now to be able to really predict something clinical right now, and what do you think is the potential, say, 2 years, 5 years from now? Where
So-
are we not leveraging?
So it is the question is not about the technology. The technology itself is much more mature.
Right.
The problems are still there. The problems are related to data, right, and the algorithms. They are nothing to do with like, just think about that. There is a notepad and there is a pen. You can write essay, but notepad and pen themselves don't write. The author is going to write that thing. So similarly, the algorithms, that's where that is still not a science or engineering work. It is still art, much more. That's why as of now data scientists are paid much more. But now the technology in that space is maturing rapidly. So there are algorithms which are like, for example, Graph Labs has launched a platform where you can auto select algorithms. Similarly, Apache Spark MLlib is actually coming up with the platform where they can do the selection of the algorithms and then quality of the algorithms. So then there is another. So there is still work going in that progress, where eventually the data scientist will be not means currently data scientist considered as a sexiest job, but in 2 years from now it won't be, because there will be all this tooling available, so that that prediction, etc., would not be that much difficult. So short answer to your question is that yes, I think the platform technology is there. Now on the technology, the applications are getting built, and 2 years from now they will be much more better for now. As of now, the current issues are that the security issue, the interconnectivity issue, that all the lack of standardization issue. So they are there. Those problems are related to the IoT healthcare specific, not on the big data machine learning specific. So those problems needs to be addressed. Okay, so yeah.
Thank you for a
what is the last one?
Where is Oracle headed with this?
Oracle is a big beast, you know that, right? It's like a 900 or whatever that pound gorilla. Oracle is everywhere if you really look at it. So, but in a way that if you ask, verticals, right? So in the big data and cloud, Oracle is doing a huge investment for starting a few years back, and now the products are coming out. If you go through the presentations and done during the last Open World, so many applications built on top of big data, built on top of cloud platform, they are announced and they are getting launched. Now, Oracle also acquired lot of companies in the verticals, different verticals, whether it's a retail or e-commerce or etc. Right? So CRM etc. They have their own applications etc. So those applications eventually now start using the big data insight etc. So there is still that transition period would be there. So I think big data in the overall space, Oracle is heavily investing, both organically as well as in the acquisitions, and putting a huge investment in the building the ecosystem around.